Good morning, everyone. We will today we will discuss about the recursion and we will try to complete this problem that we stuck previously on here, like to how we can when we have the big array, when we have the big array, how can we when we find the sub arrays and from the sub arrays, how can we calculate each individual array and yes. So when we have the big array, like this is the sub arrays we found all, how can calculate each combination of sub array and found the uh, as the question suggests that we need the yeah. So which three combination will get us the maximum possible sum that we need to found. So we then for that case we need each individual sub array should be calculated with every two combinations, right? Every three combinations. So to solve that, we need a brute force method. We will anyhow we are implementing it in a brute force method. So how can we so let's work on it and check it out. uh, to solve this problem, last time we discussed and we found come up to the solution that we need to use recursion. Let's revise that part and let's come up why we thought that we need to do in a recursive way. So here I also forgot. Let me check once. But no recursion or backtracking, how we can come up with a solution. Okay. Yes, you are 100% right. This is the exact thought process. I have all sub-arrays in a big array. I need to pick every possible combination of k sub-arrays. I need to pick every possible combinations of k sub-arrays, and I need to calculate the sum of each combination, return the maximum, and return the maximum. So to calculate sum for each combination, calculate sum for each combination. Every possible combination. Calculate sum for each combination. Yes. So here is the reality check. How do you actually generate all combination of k items in the code? If k equals to 2, we need two loops, right? Then we two specific combinations we can keep. If k equals to 3, we need three loops. So three combinations we can pick. If k equals 5, you need five loops. If k equals to a, you need loops, multiple loops. Because see, so small k. If k equals to 1, we need one loop. Okay, selected one and we calculate the sum and we done it. If k equals to 2, we need two different type of sub-arrays. Why? So in our previous implementation, what we are doing, we are first like I equals to 1. If I equals to 1, so when we are pointing to this, we are pointing to the first element 4. If you consider 0th index 4, we are pointing to that specific element, and then that's my screen little bit. Yeah. I am pointing to that specific element, that is if you will say it as a 4, and then what I'm doing, first calculating the sum, like maximum and minimum, and then I'm what I'm doing, maximum and minimum of that, I'm subtracting it and inserting it, obviously, and let's see that if this is maximum, correct? 4 2 we get, and we need to see that if this is maximum, if the k is 1, it is saying. If k is 2, what we are doing, we are uh, same, we are pointing to the first element, and then we are using j to calculate the second part, and we are attending to k minus k minus 1, and if k equals to 3, then it will go to 3. But what happens after every iteration, like for example, if we consider uh, first index k equals to 4 and 4 2 happen, then it will come up here, and again k needs to be iterated to second index, right? Then k, for first, for the 4 we have these two, but the 4 we don't have these two again, and 4 we don't have these two, so that specific solution did not work. So this is a solution, like if k equals to 1, then you can have one array. If k equals to 2, you can calculate both at a once. Here selected ij both, right? Now k equals to 4, k equals to 4 2, then this 4 have all specific combinations of 2 to index. K equals to 3, then 3 arrays. So this is a problem. K will be increased, and the number of values of the k, number of loops will be increased. So we can't go with this way. Each time we add another level of picking, we add another for loop. So each new loop starts from previous index plus 1. We are building a list ijm that grows. So in our problem, we also find out that yes, for small arrays it is getting uh, maximum, but it is not exactly doing. It is not a brute force way. It is a wrong implementation we did in our previous part, because we are not mentioning. We are not combining, doing checking the maximum and minimum all specific combination, like 4 with 4 2, zeroth index with first index, second index, zeroth index with third index, fourth index, zeroth index with fifth index, sixth index, zeroth index with seventh index or eighth index. We are not doing it. So as I'm not doing it, so it will not give us the all possible, we don't have then all possible maximum. So if there is a small sub arrays, like big array consider a small number of sub arrays, then it will be fine, we can get one maximum. But if it is a very big array or something, the indexes are more, then it will be a problem. So then we understood like how can we calculate. Then we found that if you go in this way, like I or j with looping structure, we are getting it like if k equals to, we need two arrays, then we need to do the maximum of both and check the like get the maximum of both, like subtraction of max minus mean we need to do, and then we need to do max minus mean, and then we need to calculate it, and we will find out which specific combination have the maximum element. But here also the problem is that, as we understood, that there are sub arrays, there are multiple level of sub arrays we required. So if k equals to 3 will increase, then k have three loops required. So this will not go like this, because anyhow if k equals to n, then n loops we require. So what we can do, if k equals to I, because the Python needs to know at code writing time how many for statements to write, but k is only known at runtime. The recursive inside, think about it like, what if instead of writing nested for loops, we had a helper function that says I need to build a combination of size of k. I will pick one item now, then ask someone else to build a combination of size k minus 1. Okay. Hmm. Let's understand the console. So here we understood that we need to go for the combination of recursion. So let's go step by step process. First learn what is recursion, and then we will proceed to solve this problem. So before we dive into recursion, let me check, have you ever heard of recursion before? Even if have not used it, maybe you have heard the term. Yes. Do you understand how a function works like? Can a function call another function? Yes. Inside it. Step 2. Imagine you are a manager, count 100 items. Approach 1. What you know loops. Yourself 1 by 1, 3 by 100. Approach to delegation. You count one item yourself. You ask your assistant to count the remaining 99 items. Your assistant counts one item, then ask their assistant to count 98 items. You continue until someone counts the last item. Says done. Then everyone reports back to the chain. Question: does this delegation idea make sense? Each person does a tiny bit of work, then passes the rest to someone else. Relating this to our problem. For our problem, we need to pick case average from big array. Think of it like this delegation. Pick case average starting from position start. Your approach. Try picking the sub array at position start. Ask your assistant. Now you pick k minus 1. Sub array starting from position start plus 1. Try picking the sub array at position start plus 1. Ask your assistant. You pick k minus 1. Can you see pick k items become pick 1, then question to pick k minus 1. Let me know if this analogy makes sense so far. Let's say him, yes, I know about, I heard the term, recursion, but never used it. Never used it. Yes. Yes, your analogies make some sense, but not able to get the clarity. Not able to get the clarity. What happened to this plot? Okay. Like your task, pick any two candies. Pick from the rest. Okay. Pick one, option one. Pick one, then pick from the rest. Option two, pick this, then pick from the rest. Pick this, then pick from the rest. You have to write the first in candies, for second in candies, after first, print first and second. Are you with me so far? This is just you already know nested loops. Yes, मुझे अगर दो कैंडी पकड़ना है तो मैं कैंडीज में जाऊंगा, पहला कैंडी पिक करूंगा, for first in candies, for second in candies. Yes, print कर दूंगा first. Think differently. पहले पिक किया, पहला कैंडीज में गया, पहले आपका पॉइंट किया, सेकंड में गया तो एक बार में फर्स्ट सेकंड दोनों प्रिंट कर, पहला पकड़ एक बार में मेरे को दो पकड़ पिक करना की बार, तो एक ही बार, so we need to do one time three different combination if k equals to 3, right? So that's the reason we go for the nested loops. This is a good point in insight. So what if I gave you a magic function called pick remaining candies left, how many? Pick two candies from it. I will pick myself one candy. I call my helper, hey, pick remaining candies. One more candy from what is left. Then helper does the same thing. Needs zero more. Done. We have these two. Needs zero more. Done. We have these two. Fix this. Needs zero more. I try picking myself this. I call my helper function. I pick other two candies. Right? Yes. So key insight is, instead of you doing all the work with nested loop, you do one step, pick one candy, then ask a helper to do rest. Can you see how two candies break down into pick one candy yourself, ask helper function to pick three candies would be, and pick three candies would be pick one candy yourself, ask helper to pick two candies from what is left. For five candies, I will say I will pick one candy, call helper to pick four candies from what is left, from what is left. And print five candies and say done. The helper is you. When you call the helper uses the exact same method you used. Pick one candy, ask the helper to pick the rest. The helper does the same thing. You need three candies, pick one. You call yourself, pick two candies from. You pick one candy, you call yourself, pick one candy from. Base case, when you need pick zero candies, we are done. Recursive case, how do we break down the problem? Pick one candy, call yourself to pick k minus one. Okay. What is the base case? When zero candies will be there. There are two cases for the recursion. So till now we understood that for recursion, uh, we have we need to do like this. Like we are calling. So for example, I am picking one candy. I'm calling myself to pick another two candies, two remaining candies, right? So this is the recursion only. I first time I did it, and then calling the same function to do the rest of the process. So it is saying that recursive cases pick one candy, call output to pick k minus one candies from what is left. Base cases when we are done, like zero candies when we will say okay, we are done, or we return the output to someone. We can do like that. Yes. Base case when zero candies remain. I need to pick k candy, two candies. I will pick one candy and call myself to pick one candy every time. That I understood. I'm saying, I'm thinking that I will pick one candy and call myself to pick every time till two candies pick, till two candies pick. Let's see what will happen. Yeah, base case, we need to pick zero more candies, not when zero candies remaining. For example, I need two candies total. I already picked two candies. How many more do I need? Zero. Then done. You can pick one candy, call myself to pick k minus one. Yes. Total candies I need to pick two. Then one more additional candies I need to pick, right? Until k equals to zero. And when zero will be there. So let's do this. Write the code. Let's given the code. Pick candies, k and selected. If given k equals to zero, print done. We picked and selected. Obviously. In range of length of candies. So candy, candies, candies of I and candy. Pick candies from position 1 is selected. Selected like how many candies picked. Selected dot append, it will do the how many candies we are picking. Okay. And we are appending on it. So remaining candies we have, how can I know? Candies I plus 1. Now pick k minus 1 more from the rest of the candies. Remaining candies, how can you found? Till y plus 1 to till end. Pick candies, it will get us remaining candies k minus 1. First time when you implement, you pick the one first candy you pick, and you tell this call this same function to do the rest of the poly. Selected dot pop, what it is? Selected dot pop. Let's telling k equals to 2. For example, how many candies I need to pick? Selected is empty. I equals to 0. You pick one, put it in. All pick candies. Now we have these three. K equals to 1. Obviously, because k minus 1 candies it will go. Remaining candies we have this length, or we can say like, okay, these are the remaining. Selected this. Selected this. Yes. Then I equals to 0. Again I equals to 0. Take this candy. Selected dot, what this is doing? Let me ask what this is doing. It's doing pop do remove. Okay, selected list for different combination. Let me know. So why? still selected has been managed. Now try next combination. Hmm. You can't do pop. Pop will happen. See, when pop will happen, wait, okay, let's go line by line. We can pick this to call pick candies, k equals to 0, selected is this. Now we will say done and we print it. After this, I have doubt that when this pop line will execute. When this pop code, when this pop code will execute. Execute as it is present in our uh, inside the for loop and below the recursive method called recursive method call. Step by step execution. Let's see. Line A. It is line A selected append line A execute I equals to 0 selected line B pick candies, it will pick that k equals to 1, then line B pick candies will execute. How many candies? Now remaining code which is this k1 selected, pause is here, call to will happen, it will select append both line B k equals to 0, all three k equals to 0, print done, return, goes back to the call. Oh, goes back to the call to, it will come here. When it is saying goes back to the call to, yes, it will come to line B. Then it is selected pop. Now this will run. Well, now both are selected, so both will be come out. Pop method will call. Now this run or loop ends. No more candies. So here I have doubt. So okay. Pop क्या करता है? Pop will do. Pop will remove one by one, and obviously this, then again it will go to the for loop, and for loop we have empty, anyhow empty candies, because wait, pop is happening on selected. How you said loop ends, loop ends. I need more clarity. Whatever we have doubt, we need to clear it out one by one. So this will be better if we initially get the clarity, like what are the issues, like initially before writing the code. Okay, now let's see. Let's say call to pick candies. Okay. This call returns k equals to 0, right? Selected dot pop. Now selected of this. Now the for loop checks, are there more values of I? Okay, because we are looping through candies, which is first iteration I equals to 0, process candy at index 0. Means so when we are picking, wait. So let's go here. So it will pick the candies. So remaining candies तो हम बता रहे हैं उसको obviously. Get me 1 minute. Let me drink some water and come back. So let's get back. So let's understood this code flow by executing step by step. Okay, let's tell me, Claude, can you print line by line by explaining me code execution flow, code execution flow, execution flow. Then our confusion will be clear. Yes, obviously. Now I got the code flow. Let's see how this code is executing one by one line. So here there are, let me trace every single line execution. Pick candies. Line 1 base case, line 2 this, line 3 happen, line. So print execution. Call pick candies. We have two candies, K2 selected empty. Line 1. Check if K equals to 0. No, K equals to 2. Keep if block. Line 2 will execute. Let's keep this code here. Get this code here. Hmm. Now it comes to line 2. It have two candies, obviously, range of 2, 0, 1. To start with 0. When it start with 0, it comes to line 3. It will get the candies because already one candy is picked and selected. Yes, candies of 0 is picked and it added to the select. Uh, then line 4, make the recursive call. So here we will say, okay, now we have this one candies. So our for loop will pause here, and then again now k equals to 1 only remaining. So from the pick candies, only one is now present, selected also 1. K equals to 1, so it will skip the step and it will do the same process. And here selected candy, now selected have two candies. State change, make again recursive call, but it have now candies is now empty. So and k minus 1, like 1 minus 1, 0. So it will call this method, and when it will enter, it find that k equals to yes, execute if block. Now print done, output done, return the method. This function exit. When returning the previous call, it is resume the step 8 because it is yes. So when it resume the step 8, selected dot pop will happen, and it removes this. Now selected have this. Okay, so step 8 is that when recursive call is happening, it is pausing the flow. Obviously when flow is going on, it is pausing it. And once it will be like, one second, yes, once it will be like returning the function. Now when the function will return, now it will resume this function. So after the next line, this specific line 5 will start. Then it have to, first it will first pop out, it will happen. uh, yes, now here it remove the first one. Now this is line 2, for loop checks for next iteration. It will go to line 2. Okay, we are at I equals to 0. Is there I equals to 1? Is there I equals to 1 range of 1? No. So loop will be end because obviously 0 to 1. What should be range? I have a doubt here. Range will be, how range will be 1? Range will be 0, right? How range will be 1? Range will be 0, right? Because there is nothing in the candies array. I have previously the confusion this, because if candies will be empty, once again 1 minute. Gives you number 0 to n minus 1, not just number n. Correct. Let's check step 6. Candies will be this. Okay. Obviously, it will go to the previous state. Wait. Line 2 start for loop. No, no. Wait. We have confusion on step 20, right? Pause here. Enter the new function call. K equals to 1, 20, line 2 start for loop. Goal. Wait. I go a little bit up. I think there is some miscommunication happening here. Line 2. I have doubt in the line 4. Candice entering the new call. Call Candice K equals to 1. And keep the block done. Pause here. Step 8, call candies k equals to 0. The block will execute, return the resume the step 8, and the step 8 will resume. Obviously the all finished for it. Then line 5 will execute, it will pop out. Step 13, line 2, obviously it will go I in the range is there I equals to 1. For loop we are at I equals to 0. So I am down in step 13. So what is the doubt exactly? So in this, before step 9, step 9 executes, we have this line. What is the array name? Pick candy. Where candies, where this line, where candies array is empty, empty. But in step 13, how range is 1. Range is, so we will continue after this. Because after almost 10:30, I think from 58 minutes of stream happened. We'll continue this in the evening. Let's complete this part only. Step 9 call happen. Okay, third call. Step 9 we back to different function where candy is this. So here is a point we need to understood, like when it is saying the function is paused, so, means the state also is changing. State of the candies array is also changing, right? So we need to understood that point, that we will continue up in the evening around 6:30 or 7, and we will discuss about it, like how when the call is, when here if you will see uh, here when the returning to the original, returning to the entering the new function call and returning to the original call. So when we are returning to the original call, our state of the array is also changing. We are returning the previous state. So how it is happening, that we will understood how the recursion, then we will understood how the recursion is happening, then we can able to solve the problems. So this is the recursion related issues I am thinking. So let's work on it. We will work on it in the evening. Thank you.